Okay, we are going to start a new chapter and we're going to be in section 11.1. This chapter is going to look at the nature of finance. This chapter is very heavy on calculator usage. So I'm going to recommend a calculator for you to use, but if you have a calculator that you like to use, feel free to use it. I'm going to have one that I'm going to pull up on the screen that I'm going to show you and work through the steps with you. There are also some formula sheets that I'm going to upload on Canvas. I highly recommend that you print those out and have those handy to use as we work through this material. You're going to want to use those formulas all throughout this chapter. So let's go ahead and get started. Okay, so this is we're going to start out talking about simple interest, and this is the calculator that I like to use for this particular chapter. This is the calculator from Desmos.com, and so this is their scientific calculator. And if it's free for you to use, and so you're welcome to go to desmos.com/scientific, and you can pull that up and feel free to use that along with me, and you can follow along as I go through the examples as we're working through them. So you'll see me using it on the screen as well. So we're going to start out talking about simple interest. And you're probably familiar with this particular formula. You've probably seen it before, but interest is equal to the present value, or you may have heard it referred to as the principal. So the principal times rate times time. Rate is always typically given in a percentage, and then time is given in years. And so that's a very simple formula. Let's look at an example. Calculate the amount of interest earned, $523 at 6 1/4 simple interest for 3 years. Now what we're going to do is we're going to take all of this information and we're going to plug it into this particular formula. So this particular formula, so we want to take all of these pieces of information, plug it into this formula. So there's my formula. And then what I did is I said 523 is my principal. Now notice my rate is 0.0625. That is 6 1/4% in decimal form. So 6.25%. And if you put that in decimal form, remember you have to move your decimal place 2 places in order to put it in decimal form. And then times 3. So now let me bring up the calculator and let's look at how that would look in this calculator. So you could do 523 times 0.0625 times 3. And you can do it all together in one time and then press enter, and you get 98.0625. Okay, so that would be 98.0625. Now remember that we are talking about money, and so anytime in all of these, your final answer with money is going to be 2 decimal places. So you're going to round that to 2 decimal places. So in this particular case, 98.06 would be, that would be your interest. And so, so here you would have 98.0625, and then whenever you round it, you would have 98.06 cents. So $98.06 would be your interest. That would be the amount of interest earned. All right, so that's just simple interest. So not too bad on that. Now, what if you were to ask, what is the future value after 3 years? So now the future value, what you want to do is basically, the future value is often represented by the letter A. So then you will see that that's the principal plus the interest. So the present value plus the interest. So what was the present value? $523 plus your interest. So all you have to do is add those two together. When you add those two together, you get $621.06. So that's not too hard. Now, there is a formula, and you will find this on your formula sheet, that will give you the formula right. It'll give you that future value, and you have a lot of homework problems that ask for the future value. Okay, and so if you are asked for future value with simple interest, you can use this formula right here and go straight to it, and you'll see we're going to use that in just a second. But anyway, I wanted to show you. So, and let me just show you how we can put that straight into this calculator. So if I wanted to put this straight into the calculator, I would say 523, and I'm going to put it all in one step, okay? So I'm going to use this parentheses 1 plus, and then I'm going to use another parentheses, 0.0625 times 3, and then I have closed parentheses. I have 2 of those. So notice the reason why I like Desmos is because it looks exactly like it looks on the screen. And so I can make sure that it looks exactly the same. So when I do that, then I can hit my enter, and I get, so then I can double check and make sure that I got the same exact number, which is 621.06. So notice you can go straight to the answer without having to go through multiple steps. So that's the beauty of this particular formula right here. Okay, so if you don't like using that formula and you want to go through all of these extra steps, you can do that as well. So I just like, to me, it's easier to go straight to and put in that formula all in one step and not do a lot of rounding. And we're going to talk about that as we go on. All right, let's look at another example. So this is your homework problem number 9, one that is similar to that. And I put simple interest, not so simple, because it turns out to be not so simple. Find the total amount that must be repaid on the following note described. $9,764 borrowed at 18.5% simple interest. What is the total amount to be repaid 3 years and 125 days later? Okay, so this particular example is only difficult because it has this extra part in it, 3 years and 125 days. So they gave you your time, and the time is not all in years. So that makes it not so simple. So here we are talking about finding the total amount that must be repaid. So that is future value, and this is simple interest. So on that formula sheet, you should be able to find future value for simple interest. Now, whenever you look at that, you're going to find that the future value for simple interest is this formula, A is equal to P times 1 plus RT. Now, you're also going to find a note that says that if you are given the time and it is not all given, like if you're given the time in part of a year, so like this part where it says 125 days, you have to use, they call this an ordinary year. So if it is simple interest or compound interest, which we hadn't talked about compound interest, but either simple or compound, you are going to use the magic number of 360 instead of 365. I know that we have all been taught that there's 365 days in a year, but for simple interest and compound interest, the magic number is 360 for financial reasons. So you'll see what that means here in just a second, because that is, for financial institutions, they use ordinary interest when they're calculating these formulas. So how that's going to come into play. So let's take a look how that makes a difference. So when I plug these things into the formula, this is what it looks like. And let me show you where these numbers came from. So A is the future value, which is what I'm looking for. P is my present value, which is 9,764. Okay, 1 is just 1, the number 1. Okay, R is my rate, which is 18.5%, which I turned into a decimal, 0.185. No problem there. Now, then you have T, which is your time. Now, the time is that's a little tricky here. So my time is 3 years plus part of a year. Okay, so the part of a year is 125 over 360. So this is where this is tricky, okay? So it's 125 out of 360 days. And again, that 360 is ordinary interest. We use 360 when we're talking about simple interest or compound interest. Okay? So now I have all of this, and here is where you have an option. There are going to be some of you who are going to say, yep, no problem, I'm not intimidated by that calculator, and you're going to pull up the calculator, which I'm about to do now, and we're going to plug this big ugly thing into the calculator all at one time, and you're going to be done with this problem. You're going to hit enter, and you're going to say hallelujah, and you're done. And then there's going to be others of you that are going to say, I hate that calculator. It makes me really nervous and I just can't do that. And I have anxiety attacks. And that's okay too, because we're going to take care of you here in a second. All right. So for those of you that are not intimidated by this calculator, let's work this problem. All right. The others of you, you just watch it. Okay. And you might want to practice, because I might win you over here in a minute. All right. So let's try it. We're going to do 9764, and then I'm entering it just like I see it on my screen, times 1 plus 0.185. Oh, I need another parentheses. 3 plus. Now, I need to do a fraction, and what I love about this is, you see this little fraction right here? I can hit that and it'll give me a fraction. Is that not the cutest little thing ever? It will do that for you. I love this thing. 125, and then I can take my mouse and go straight to the denominator and type in 360, and then I'm going to So then we can just close our parentheses. So I'm going to hit the close. That closed this first set of parentheses on the inside. And then our last set, we can hit enter. And you see that the answer is this $15,810. And if I rounded that, it would be 22 cents. And that's our answer, and we're done with this problem. And so you could just write that answer, type that answer in, and you are totally done. Now, I know that some of you, like, that's just a little bit of overwhelming. That's overwhelming to you to try to do all of that in one big long time. So we can break that up a little bit. So I'm going to show you how that looks a little bit if you need to break that up. Okay, so if you need to break that up, what we would do is like our order of operations. So what we would do is we would come in here and we would want to work from the inside out. And so we would start in here, and so that's my answer from that one. But what I would do is I would probably take my calculator then, and I would say 3 plus, and I would do my 125 over 360, and that gives you the 3.34722. Now, you need to make sure, if you notice here, like I have gone through and on here, I have gone through and I have gone out several decimal places. So I've gone out like 5 decimal places. You need to go out at least that many before you round, because if you don't do this, if you round like just to cents each time, your rounding is going to make your answer be off. And then if your answer is off even by just like a couple of pennies, then your final answer will be off. And so that makes this become very aggravating to my students. And that's where this section becomes really, really aggravating. So the next step would be to do this 1 plus 0.185 times 3.34722, and you get this number. Then you would do these two numbers, and you still get the same exact answer. So if it's easier for you in your mind to do this in small steps, you are welcome to do it in small steps. If it is easier for you to do this in one big step, do it in one big step. You just do it however it is easier for you to do it. And that will work just fine for either one, okay, because you get to the same answer either way. Let's look at another example. On this example, we're looking at compounding interest, and compounding interest, you'll look on that formula sheet. You can compound your interest multiple different ways throughout a year. And so this particular, you have the formula changes a little bit. And so you'll see the compounding interest formula here. And so I'm asking you to find the future value for $795 at 6.3% compounded quarterly for 5 years. So I'm going to take my formula, and then I'm going to plug everything in to this formula. So now you just have this extra layer. You have an extra variable n. And n is going to be depending on how it's compounded. This particular formula, in this particular case, you are compounding quarterly. And so if you're compounding quarterly, n is going to be equal to 4. And so if you look at that formula sheet that I gave you, it will have the formulas on there for you for quarterly, monthly, semi-annually, and so on. And so I tried to list all of those out there for you, and so that should help you out a lot. So on here, again, I plugged everything in just like you see it. So we have 6.3%, and then 4 comes from compounded quarterly. T is 5 years. We don't have any of that crazy so many days, so that makes it just a little bit better. And so what I'm going to do is I'm going to show you again how I plugged that into Desmos calculator, okay? So, because again, this is the hardest part of this. So let me show you how this looks. We're going to try to make it look exactly like it does on here. 795 parentheses 1 plus, and I'm going to give myself a fraction, and then 0.063 over 4. And then I'm going to close my fraction. Oh, I don't need to close it down there. I'm going to arrow over to the outside, and then I'm going to close my fraction. Okay, so all I did was just arrowed over to get to the outside. Now I need to make that to be an exponent, and so this is my exponent key, this a to the b. So I'm going to do that exponent right there. Now this needs to be 4 times 5. Now you could just say that's 20. 4 times 5 is 20. But if you're not good at doing that math in your head, you would do parentheses. So you can do parentheses 4 times 5 and then close your parentheses. So you really just kind of make it look like you see it right here. So let's check everything. 795, 1 plus the fraction 0.063 divided by 4, and then exponent 4 times 5. So that looks like everything to me. So then I'm going to hit enter, and it's 1086.69. So this would be 69 because there's a 5 right here. So that would round this up to 69. So that should be my answer. Now, if we need to take this again in smaller steps, let's see what that looks like. Okay, so taking it in just a little bit of smaller steps. So that's all in one step on Desmos, right? But if we need to take it in smaller steps, we can. So taking this in smaller steps, we would get, so doing just the inside here, we would get 101575, and then I did 4 times 5, which is 20. And then you could do all of this together, and you would still get 1086.69. Okay, so again, you can take it in smaller steps. Just remember that you need to take it out about 5 decimal places. So before you start rounding. Okay, so that's compounding interest. So this was future value compounding interest. That formula is on that formula sheet. Okay, now we are going to find the present value. Now the present value, we've been looking at future value a lot, so where do we get present value from? So you're going to have problems where they ask you for present value. Let me show you where present value is coming from. So the present value is actually from the formula. So the formula says that the future value is equal to the present value times 1 plus RT. So what we can do is this is what we want to find. We want to find the present value. Now we can basically look at this whole thing, 1 plus RT, because it's in parentheses. I'm going to treat it as, so I'm going to do a little bit of algebra here. I'm going to treat that whole thing as if it was all together. And because it's in parentheses, it is all together. I'm going to just decide that it's all together, and I'm going to keep it all together, okay? So what I want to do is I want to solve this equation, and I want to solve this equation for P, which is the present value. And so if I want to solve this for P, I want to get P by itself, and so I need to move this over here to the other side, okay? So I'm going to divide both sides by 1 plus RT, everything that's in parentheses. If I divide it by 1 plus RT, and I divide this side by 1 plus RT, then I will get the present value by itself, which is what I want on that formula. So I'm just going to show you, and I just want you to watch this, okay? So just watch it. You're not going to be tested on this. Just watch it. Okay, so this is what it looks like. So I divided by 1 plus RT, I divided by 1 plus RT, because if you remember from algebra, whatever you do to one side, you have to do to the other side. Now, these will cancel each other out, okay? And you get A over 1 plus RT. So that is my formula for the present value of simple interest. So that is where this formula comes from. I actually gave you this formula on that formula sheet. So the present value formula for simple interest is this formula right here. A divided by 1 plus RT. Okay, so that is the formula that I'm going to start with. If I'm looking for present value, this is what I'm going to plug my numbers into. So when I do that, I'm going to say how much to achieve. That's my future value, $4,000, and then 1 plus RT. So 1 plus 0.035 times 3. So very quickly, let me pull up my Desmos and show you what that's going to look like. So, and that would be a very ugly fraction, but we can do ugly fractions because Desmos lets us. All right, 4,000 on the numerator. In the denominator, we're going to have 1 plus 0.035 times 3. And then I'm going to close my fraction, and I'm going to hit enter. And so there you have the answer, 3619.91. So that is the present value. That's the answer, 3619.91. So it makes it really easy. Okay, so let's see how this plays out. So you can do this by simplifying if you want to. And that's where you get it. So again, you can take it by multiple steps, or you can just plug it in and go straight to Desmos and put it all in and round it. Okay, so those are your different options. Okay, now we're going to look at continuous compounding. Continuous compounding is a little bit different than our other compounding. So like its name, it compounds like on a daily rate. And so whereas before we were looking at the magic number for yearly as 360, whenever you see continuous compounding, you have to consider 365. So that is the difference. Anytime you see continuous compounding, you're going to use 365. That's the only time you use 365, is when you see continuous compounding. So I do have that note in your formula sheet. So just make sure continuous compounding, you use 365. So that's going to come out in this particular example. So it says find the present value to achieve 250,000 at 8.95% compounded continuously for 8 years, 155 days. Now, if you look on that formula sheet, I have given you a formula for the present value when you are doing continuous compounding. So that formula is, let's see, P for present value is equal to A times e to the negative RT. Now, e is an irrational number, and that irrational number is 2.71, and it goes on and on and on forever. So let me show you what that's going to look like. So on your calculator on Desmos, if you go to the function key, I can type in e and then to the first power, and it's this 2.71828, and it goes on and on, like I said, forever. And so we are going to use that in this financial formula. So that's what this means. This is a negative power whenever we are looking for the present value. Okay, so let's plug this in and see how this works. So when we plug these values in, we get 250,000. So at the rate is 8.95%, so it's 0.0895. Make sure you use the negative. And then the time, here's where this comes in. We have 8 years plus 155 days. Whereas before we used 155 over 360, here we are going to use 155 over 365, because anytime you use continuous compounding, you're going to use 365. Okay, so now let's pull up our Desmos calculator and see how this would look. All right, so we're going to do 250,000. And then to get to the E, you have to go to this function tab. So I'm going to go to function, and here's my E. Okay. Now, when you do E, it automatically gives you this little exponent. If it doesn't give you an exponent, you can always click the little exponent key if you need to. But it should give you the exponent. Okay, so then I'm going to type in a negative, which is my minus key, 0.0895, and then my parentheses, 8 plus, and then I need a fraction. So I'm going to get my fraction, 155 over 365. And then I'm going to close my parentheses. And that is my answer. So let's double check and make sure we typed everything in correctly. So 250,000 e to the negative 0.0895, 8 plus 155 over 365. So it looks like I did everything correctly. 117,619.41. Okay, I asked myself, does that make sense? And it does seem like it would make sense to me that this would be the right answer, that that would be a present value. So that's what I'm getting, 117,619.41. Okay, so again, if that's all you would have to do is just type that. That's your answer, 117, 619, 41. If you want to go through this and you wanted to simplify this a little bit, you could. Whenever you're dealing with problems with the E in there, I just kind of recommend that you put it all in at one time. It's typically just easier to do it that way. Once you start working with these with the calculator, I think that you'll find that you will get used to it and it'll be easier for you to just use the calculator. All right, I have one more example, I think. Okay, you have several examples in your problems about inflation. Most of these problems, you can assume if it says inflation, they're wanting you to do the future value using continuous compounding. So you would use the future value formula, continuous compounding. There are a couple of them that you can use the future value with just regular compounding. And if it doesn't say the continuous compounding, but you should know it in the problem. But on this one, we're going to use continuous compounding. Find the cost of a cup of coffee in 9 years, assuming inflation of 7%. So I'm going to use that formula. I'm going to plug everything in. And so what we did is 2.5 E times 0.07 times 9. I plug all of that into my calculator, and in 9 years, that same cup of coffee will be $4.69. So all of that goes into your calculator and you would get 469. Okay, so I hope that this has been helpful, and if you have questions, this particular section is just tedious using the calculator. So I hope that you saw that, and so hopefully that this will help. If you need my help, you know how to reach me. Send your professor questions or messages if you should need it. Thanks so much. You can actually just take your mouse. Well,